friends, new friends, and to the many who are watching the live stream. These are big moments in the life academic. Arguably, isn't that a wonderful backdrop? Arguably, they're the best moments, the biggest moments in academic life. Because tonight it is with huge admiration and warmth I introduce Professor Pamela Heaton to you. To many of you, she needs no introduction, but the career is significant and I want to say a little bit about it. For the outsider, the intellectual endeavour that is psychology conjures up intrigue and excitement at every corner. To understand human behaviour in all its complexities fascinates and quite frankly even unsettles the rest of us. It scares the wits out of us that you guys are forever putting us under surveillance of one kind or another. But Pam's contribution is truly great. Will be, this is an appropriate word I think, will be treated to a recital of her recent work, a marriage of both her passion for music and of psychology, examining children with autism and with Williams syndrome. First of all, though, I'd like to say a few words about Pam's journey and about her time here at Goldsmiths. She grew up in Hull when, in her own words, education wasn't for working class girls. Would that we could say tonight that that was entirely different today? But Pam, you left school at 15, something which is not common among most academics, let alone professors, but is a significant fact. Hull wasn't an easy place to be. It's a place I happen to know very well. A city flattened by war, and one that had lost much but not all of its grandeur, of its self-importance. However, young Pamela found salvation in music, in playing the piano, and in singing. She quickly realized that she had a genuine talent and began making efforts to pursue it. You completed your GCSEs and O-levels at night school on top of a full-time job. That gave you the chance to enroll at music college. And Huddersfield College of Music became the catalyst to explore your talents. And you still look back with enormous affection and gratitude to the opportunities that wonderful environment gave you. There you got the opportunity to study abroad and evolve your art still further. Eventually you would sing professionally, performing with orchestras as a classically trained vocalist. As we chatted, I said to Pam, God, my favourite place in the world for serious music is the Wigmore Hall. And casually, almost offhand, she said, I sang there. This is a significant career in music as well. However, tragically, an illness deprived us of that performing talent and affected her most precious thing, her vocal cords, which meant that for many people that would have been a terrible crisis. But Pam, of course, is made of stronger stuff. She said she had a realization that music wasn't the right profession for her, and she recast herself. And this is where Goldsmiths comes in. And she took a part-time degree in psychology at the same time as juggling and probably literally her young child. Another exemplary role model chapter in your life, Pam. When hearing the journeys of professors, as I'm privileged to do in this role of leading academics, almost always there is some defining influence, a character or an experience that has the power to engage, to inspire, to lift the sights of the young scholar. In Pam's case, that role was performed by Beata Hermelin, because notably Beata, known as Ate to all of you here I'm sure, also had her teenage schooling interrupted and took night classes in psychology when living in London. Perhaps unsurprisingly, the passion of these two powerful ladies fused and you became a remarkable duo. Ate's influence, you testify, stays with you still. But if any of you doubt the power of an academic to alter their field and to bring great scholars into the field, listen to these stories, because every single scholar I've spoken with have a biography that speaks of someone who suddenly took their emerging interests and fashioned them in a new and different way. That's what Ati did for you, and boy, are we grateful. Together, Ati fundamentally applied general experimental psychology to the study of people with learning disabilities and initiated a series of studies on autism that was the earliest of its kind. In the presence of such an academic lead, Pam synthesized her interests with musical savants to focus on children with autism too. What followed was a flow of research on pitch recognition and musical aptitude in autistic children. We'll hear much more of that tonight from someone rather more expert at it than I am. Pam's research is extensive, and in her words, she sets out to myth-bust many of the misconceptions that most of us still hold, most of us outsiders still hold about autism. We should pause to note, however, that this isn't just a research career, because Pam also has a passion for teaching. Being a performer at heart, she describes passionately her love for storytelling to students and watching how the narrative captures that passion in young people and gives them a filing cabinet into which to put their learning. She also describes winningly those times in her research when she'd sing with young children. And it's a very good way to capture, reminding any of us, if we need to be reminded, that research is immersive and intuitive, as well as clinical and profound. The passions come together with science. In my own view, the teaching and research in your field, Pam, is compassionate and scholarly and socially essential. It is with enormous pride and respect, Pam, that I'm so pleased to be here tonight to welcome you to the stage, Professor Heaton.
Thank you, Patrick. I thought I'd start my talk by talking a little bit about the earliest interactions that I had with children with ASD. I was a mature student. I was working with Linda Pring and Artie Hermelin on a study looking at prodigious musical talents in savants. We were planning experimental studies, so we had to have a comparison group to compare with the musical savants, and so we thought that we need to recruit a group of children with autism. So I managed to find my way into a school for high-functioning children with autism. And the idea was that then, across the two groups, we would control for diagnosis. We'd have savants with autism who were extremely musically talented, and the children with autism would not be musically talented. And I think that was probably the first of the very many mistakes. Okay, so the thing that struck me most about the children was how incredibly different they were to each other. If you read books about ASD, which I did before I went to do this work, you can run away with the idea that these children are really quite similar to each other. And the whole process of having a clinical diagnosis is an extremely useful one if it means then that the individual can access educational or therapeutic services. But a real danger is that that once a child has a label, we stop thinking about them as individuals, and we make assumptions based on the label. The children that I met in the ASD school were extraordinarily different to each other. They were all true individuals with their own unique take on the world. I had absolutely no experience whatsoever of working with these children, so I had to really learn on the hoof. And I spent a lot of time being involved in the school pantomime, singing, improvising, doing lots and lots of things with the children. And as someone who had quite a lot of experience of teaching music to little children, I became aware very quickly that they had a lot of musical aptitude. They were very pitch sensitive, they were very rhythmic in the way that they thought about things. And it seemed to me that this really needed to be documented. The large majority of the largest body of research into ASD is describing deficits. So we have these constant papers describing some deficit or another deficit in people with ASD. But I thought it was very, very important to try and have a much more balanced view and have a look at the strengths that we see in these children as well. So that was what my kind of work really focused on. The research interests that I have and have pursued over the last 15 or so years with my doctoral students have been quite broad, so we've looked at quite a lot of different kinds of mechanisms in different developmental disorders. But the music studies are the ones that are really closest to my heart, so they're really going to form the basis of my talk today. Okay, so as Patrick told you, I spent quite a lot of my early life studying music. And then moving into a psychology department really caused a lot of changes in the way that I think. So I'd always had this kind of view that music is creative and subjective, and that science is involved with empirical data, and so therefore science is objective. But then I very quickly realised that science has got a very strong creative aspect to it, because a scientist has got to develop some kind of working hypothesis about the thing that he or she is interested in. So science has really got two aspects in my view. The first one is creative. You develop a narrative and you develop a testable initial hypothesis. And then the second aspect of science is really much more analytical, much more scientific, in that you're developing testable preliminary hypotheses. Okay. Where things can simply, so really, the true scientist, an ideal scientist, is somebody who will generate a hypothesis, collect empirical data, and either accept the hypothesis or generate a further hypothesis to account for the empirical findings from the various studies. But what sometimes happens is that scientists can get very enamoured with an experimental hypothesis because it tells a good story, a just-so story. And then sometimes they start to ignore further evidence, or they don't even pursue it. So I'm going to end this bit of the talk with a quote from T.H. Huxley, who says, "The great tragedy of science is that a beautiful hypothesis can be slain by a single ugly fact." Okay, so my talk's about music, autism, or ASD, and just-so stories, and I'm going to start by thinking about how we define music. So we can consider music to be the art of combining sounds, voices, or instruments so as to achieve beauty of form and expression. And an alternative one is the art or science of arranging sounds in notes and rhythms to give a desired pattern or effect. And then if we think about definitions of musicality, we often get stuck on the academy and the idea that what are musicians? Are these people up here on the right? And they're often the ones that are in your imaging studies and things. But actually, we have incredible cultural variability in the way that musicians use sounds and the way that they blend sounds to achieve beauty of form and expression of emotion. So we need a very broad, all-encompassing definition of musicality. It's probably something that everyone doesn't know about, that Darwin wrote extensively about music and musicality in human beings. He noted that music is something we see cross-culturally. All cultures have music. We have some very, very ancient musical instruments, so it's obviously been part of the human behavioural repertoire for a very, very long time. And he pondered a little bit on why we might have music. And one thing he came up with was this idea that musical behaviours may have spread through our species because musical skills impress partners and increase reproductive success. So think, yeah, I was just gonna, you know what I'm gonna say next, yeah? Think of a peacock's tail. So he was thinking about sexual selection. So music was important for sexual selection. But it's not a wholly convincing explanation, really. If I hear a blackbird singing in my garden, I know that A, he's male, and B, he's in the reproductive phase. Now, humans make music all the time, and girls make music just as much as boys. So the idea of music sexual selection is not really all that persuasive, I don't think. So then we have Steven Pinker, who was vociferously against the idea that music had any biological functions for human beings. As far as biological cause and effect are concerned, music is useless. Music is quite different from language. It's a technology, not an adaptation. And in fact, to compound the insult, he actually said that music is auditory cheesecake, which didn't go down very well with most musicologists. Okay, so for Pinker, language is very adaptive. Language is very, very important for human beings. And what he thinks happened is that music piggybacks on the cognitive and neural resources that specifically evolved for language. So the idea is that we learn to speak, and all of those abilities that enable us to speak were then appropriated for musical cognition. But the obvious problem with that is that we've got absolutely no evidence that people spoke before they sang. This is a simplified version of a model by Stephen Brown. And I think if you look at changes in hominids over time on the left side of the screen, you can see obviously a lot of changes that occurred that might be relevant to thinking about musical abilities. So the first one is obviously changes in gait. And those changes in gait would have affected the articulatory system. And that would have had an impact on our ability to speak and to sing. And if we think about changes in manual dexterity that gave man an increasing ability to make tools, it also gave man an ability to make musical instruments. And maybe most importantly were changes in brain size that enabled human beings to use symbolic representation and to think about things in a very much more complex behaviour. So we've got this explosion of the behavioural repertoire in humans over time. And according to this model, we start out at very early stages, so I think this is the chap on the left probably, where we have a referential emotive vocalization system. So apes don't just make noises for the sake of it. They make noises to communicate with each other about objects and about third persons. So it's a referential system, even amongst apes. But what happens as man becomes a more complex thinker is that we have more organisation, more structure in that vocalisation system. So we have a system called musilanguage. And this has lexical tones, it has syntax, and it has phrasing. So it has a lot of the qualities of prosody, but also syntactic as well. And man's developing and becoming increasingly complex and has more needs for more fine-grained communication. And at some point in our history, we saw divergence. So we end up with two quite separate domains of skill. We end up with language, which is characterized by lexical units and propositional syntax, and we also have music. Music also has syntax, but it has motivic and metrical and pitch blending. So the materials within the two domains are quite different, but they both would seem to need to serve some kind of function. Now we know quite well the function language serves. It's completely obvious, but it's a little bit less clear why we needed to retain music in our behavioural repertoire. And one kind of quite nice idea was one proposed by Robin Dunbar. What Dunbar said was that group singing in our hominid ancestors replaced grooming as a way of maintaining contact with individuals within a group. So if we look at these apes, I hope those are apes, Debbie, yes, good. Okay, so these apes, they within a group, they'll groom everyone. So we've seen constant grooming that is really associated with increases in group coherence. So it makes people very close to each other when they groom each other. But it's time consuming. So it constrains the size of the group, the need to be able to groom each other. If hominids could sing to each other, they can vocally groom many more individuals at the same time. And that allows for larger group sizes. And larger group sizes are good because you can then fight off invaders, you can fight off predators, you can protect land, and really importantly, you can care for young. You've got more resources to care for young, which means that you're going to see more survival into the next generation of humans. So this is quite a nice idea. Okay. And it certainly is the case that music does promote groupishness. So if we think about the way that we organise musical pitch, we have octaves, and octaves are divided into 12 semitones. If you think about a piano keyboard, we've got these really lawful divisions of the pitch space. And what that enables us to do is sing together. It's very, very easy to sing together because we have specific tones. So we have pitch information in language, and it serves a communication function. Prosody is very important in telling you whether I'm angry or happy or sad, but it's a different kind of style of arrangement to what we see in music, and music is ideally suited for singing together. Music has rhythm and it has tempo, and that's really, really good for marching together, dancing together, coordinating all sorts of other kinds of activities together. We know from quite recent work, I believe we have a PhD student at Goldsmiths at the moment who's looking at the effect of singing in choirs together. And one thing we do know is that coordinated musical activity results in increases in oxytocin. So musical activity is associated with increases in well-being, which is wonderful. But this idea that groupishness is associated with social being is kind of problematic when you start to think about people who are not very groupish. People who, for one reason or another, cannot or don't want to be closely coordinated with other people. And this is a kind of quite a nice example of the kind of thinking that was going on about this question shortly after Pinker first described his view of music. We've seen contrasting disorders in Williams syndrome and Asperger type autism. So I would call that autism spectrum disorder. In one case, we see a group of individuals who are highly sociable and also highly musical. In the other case, we see a group of individuals who display extremely low sociability and low musical understanding or affinity. Okay. So what's Williams syndrome? This is Williams syndrome. This is a child with Williams syndrome. Williams syndrome is a genetic disorder that impacts on physiological and cognitive development. We see learning difficulties in this group, but we see that non-verbal intelligence is very much more affected by the disorder than the language. So they're relatively verbal when compared to things that tap into non-verbal intelligence. So things like doing jigsaw puzzles are extremely, well, actually it's not manageable. One thing that's really marked about Williams syndrome is that it's associated with hypersociability. And this is defined as an exaggerated interest to engage in social encounters with both familiar and unfamiliar people. So parents of children with Williams syndrome will tell you that their child has never met a stranger. So Williams syndrome, according to Huron's ideas, these children are groupish, and they are musical. And then we will turn to autism spectrum disorder. So we have two different types of behaviours that we need to see in order to diagnose with ASD. And we see social, communication and interaction problems in people with ASD. We also see rigidity, obsessions and unusual sensory responses. But the second part of the diagnosis is not really so important in terms of this theoretical account of musicality. It's really this idea that they're not very social, they don't want to communicate or interact. So that led you on to say that they are not groupish and they are not musical. So let's just think about whether or not the evidence supports what Heaton says about the two disorders being very different to each other. Individuals with both ASD and Williams syndrome have problems understanding thoughts, feelings and intentions of other people. In psychology, we call this theory of mind, and there's a lot of research has highlighted deficits in theory of mind in individuals from both of these diagnostic groups. Lacroix did a study where he very carefully matched groups of children with Williams syndrome and ASD on the basis of intelligence and age, and he presented them with pictures of emotional faces and asked them to make judgments about which emotion the person depicted on the picture was expressing. And what he found was that children with Williams syndrome were more impaired than children with ASD on this task. And finally, when we diagnose ASD, we use clinical interviews. And the most common one we use is the Autism Diagnostic Observation Schedule. If we diagnose, or if we carry out the ADOS with children with Williams syndrome, a significant proportion of those children will meet diagnosis for ASD. So it's only at this most superficial level that these disorders differ. We see hypersociability in Williams syndrome and maybe a reluctance to engage in ASD, but it's a very superficial difference. And really, the empirical data doesn't really support Heaton's theory as far as contrasting developmental disorders are concerned. Now, let's think about contrasting musical phenotypes. If you go onto the internet, if you punch into the internet Williams syndrome musical, you will come up with the most extravagant claims for musicality in Williams syndrome. People are even doing genetic studies of Williams syndrome to try and find the genesis of musical ability. So the idea has become so much part of the way people think about music in developmental disorders. But there are lots of problems in these early research studies. There are problems with matching. Often the children with Williams syndrome are matched to very, very much younger, typically developing children. More important are sampling problems. So the early studies were almost all carried out in a summer music camp in America. So the children were children who were obviously liked music and would then spend the summer in a musical enrichment environment, and then they were tested in the enrichment environment. So these children are hardly a random sample of individuals with Williams syndrome. So we've got a real problem actually generalising from that kind of data from this group. And then we've also got a problem with definitional issues. So the claims that these children are exceptionally musical, hypermusical, etc., what does that mean? As a scientist, it's very, very difficult to know exactly what they're describing. So one way around this is to think about definitions of music that have really been developed on the basis of studies of comparative psychology. So comparative psychology compares behaviours across different species, and there has been quite a lot of work looking at musicality across different species. And this componential model is quite a good one in actually highlighting the separate mechanisms that are important to be able to perceive music in a holistic way. I'm just going to show you a video that nicely illustrates how a species can have one musical component to a very high degree. This is Snowball. Snowball is a cockatoo that loves heavy metal. Okay, so he's got beat for sure, but he doesn't really sing. He's not really, he doesn't construct melodies or do anything very nice like that. He just has beat perception. But we do know that there are quite a lot of species that do sing, that have extended song, you know, sonata form has been described in some species. But what's really, really important here is that the difference between humans and non-humans is that we have them all. We have all of those components, whereas different species have one or maybe two components, but not all of them. If we take this kind of definition of musicality and we look at the Williams syndrome, the empirical data from studies of music cognition in Williams syndrome, they really don't come out very well. So one study by Hopkins showed that they have delayed an atypical rhythm, so the rhythm is like much younger children, or it's completely disorganized, and they don't have very good perception of pitch. So those are quite important problems. And the second group of studies here were all very well conducted. They've got quite fairly good samples of children that are not recruited from a summer music camp. And they found that these children have really severe problems representing musical contour, which means that it'd be very difficult to recognize melodies or remember melodies. But one thing we have to remember is that in psychology, we test groups of individuals, we compare names. And it might be that when we're looking at this kind of problem in this kind of group, that it's more useful to think about individuals within groups. And in fact, that's what we've done very recently. So in collaboration with Dr. Debbie Ryby and the Northeast Williams Syndrome Research Group, we've started to look at melody perception in groups of children with Williams syndrome. So we've used a very similar paradigm to the paradigm that previous researchers have used to study melody perception. And what we found is absolutely huge individual differences. So we haven't yet got all the comparison data in, but what it's looking like so far is there are a subgroup of children with Williams syndrome who perform very, very like chronological age-matched children without any intellectual problems. So those children are doing very, very well. And then we have another group that cannot perform these tasks better than chance. They're struggling, really struggling with musical melody. They clearly don't represent individual tones in a sequence to make a tune. One of the things that we collected parent report data, and we found that all the parents reported that the children loved music. And this is very consistent with studies that have been published that have shown that people with Williams syndrome that do a lot of music are significantly less anxious than people with Williams syndrome who don't do music. And there is some work showing that if a person with Williams syndrome is in a music-enriched environment, they're better at recognizing emotions on faces. So it obviously has an incredibly positive effect. And I'm hoping that our study is going to be able to enable us to reconcile this conflict between empirical studies and what is written about Williams syndrome and music more generally. I think if we took one of the children from our group that could perform our task and put them in a musically enriching setting, like an American music camp, and tested them there, that they would do very well. Okay, so whilst I think the evidence doesn't support the idea that Williams syndrome is uniquely associated with an enhanced musicality, I also wouldn't say that people with Williams syndrome are necessarily not musical. Okay, let's turn to looking at the evidence for musicality or lack of musicality in people with autism. Because these are these are the studies that I did very early on, and because I'm very invested in these studies, I'm going to talk a little bit about the kind of paradigms that we used. So this very first study was a study that I did with Linda Pring and Pamela, and we had musically untrained children with ASD and typical development, and they engaged in what we called a paired learning paradigm, in which they had to associate pictures of animals with either a musical tone or a fragment of speech. So this is what it looked like. So the child would be shown, in the experiment, would be shown the bear, and he would be told, or she would be told, this bear has got one note that it really, really likes. The bear likes to listen to D. Doesn't like any other note except D. And over subsequent trials, we familiarised the child with the pairing between that musical tone and that animal. And we did this for 4 different animals. And then in a second condition, we said, well, the thing is the bear has also got a favourite word. The bear always likes to say ma. That's his favourite word. So we repeated the process using word fragments instead of tones. And the results were really very interesting. You can see from here that the autistic and typically developing children didn't really show any difference on encoding the word fragments. There was no significant difference across that condition. And the children with ASD were able to remember the tones as well as they were able to remember the word fragments. So for them, pairing an animal with a word fragment or with a tone was equally easy. Whereas the children with typical development just could not remember the tones. They couldn't pair the tones with the animals. And they were performing at levels that were not better than chance. I think it's always worth questioning children about what they think they've been doing in your experiment. But I wasn't able to find very much out about what was happening with the children with autism. But the typically developing children would tell me a bit about it, and it gave me a real idea about the kind of strategies that they were using in my experiment. So one child said to me, the thing was that when I saw the duck and I heard the word tar, I remembered it really easily because he's got to be really careful never to get tar on his wing, because if he does, he won't be able to fly. So in this case, the typical children were making a semantic association. They were making a meaningful correction between the word fragment and the animal. Now that strategy wouldn't work with a musical tone, and that's probably why they did so badly on the music condition. And this was a paradigm that we developed for use with children that were not really non-verbal. So it was a touch screen, and they could touch different steps, and the child would move about at different positions, and each stair had a musical tone attached to it. So we saw quite a lot of engagement with repeating back melodic phrases and finding octave equivalents of notes and things like that in quite low functioning children. And this experiment is quite a similar paradigm to the ones that have been used with Williams syndrome children. And it's quite a classic paradigm in music psychology. What happens is the children hear pairs of melodies, short melodies. They can be exactly the same, or they can be very different, or they can be just slightly different. And what typically happens is that typically developing children are really good at telling you when melodies are exactly the same, and they're really good at telling you when melodies are completely different, but when melodies are in a little bit different, they say that they're the same. And the reason for that is that children process musical melody, especially unfamiliar melodies, in a very holistic, global kind of way. So if the changes that you make across melodies maintain the contour of the melody, they just absolutely won't notice that it's actually been changed. And what we found when we ran this experiment with children with ASD was exactly the same effect. So they failed to notice holistic changes that maintain the holistic characteristics of the melody. So thinking about the definition of the mechanism, the cognitive mechanisms, we need to be musical. We see that superior melody for musical tones at the group level in autism, It's not by no means something we see in every child with autism, but it seems to be more commonly occurring in this group. We see preserved relative pitch. So Laurent Motron in Montreal played melodies in one key and then transposed them into another key, and his participants with autism knew that it was the same melody. So there's no problems with transposition ability. We saw typical encoding of melodic contour, which I just showed you, and Jessica Ward did a series of rhythmic studies in her PhD, which again showed good performance. And most recently, we've looked at perception of tempo in a musical imagery experiment, and again we found quite good perception of musical tempo. Okay, so how to interpret these findings? If we think about these results in the context of the definition that we took from comparative psychology, we would say people with autism are musical. Everything's there, there's no problems. But there are some limitations with that definition, because if we go back and think about how I described music at the very beginning of my talk, we saw that music has got an emotional aspect to it that is very, very important. And all we have so far here is evidence that people with ASD have got good structural understanding of music. Okay, we know that people with ASD can have good structural language. So we often see people with ASD who have vocabulary and grammar that is spared, good, or even exceptionally good. But sometimes people with ASD that have got exceptionally good structural language still have difficulties understanding emotions in vocalizations. So if someone talks to a person with ASD with happy voice, sad voice, angry voice, that person with ASD will find it very difficult to understand that. So what about music? If we test preschool children from the West on their perception of musical key, musical harmony, musical mode, probably, we'll find that they will consistently match major music with a smiley face and minor music with a sad face. Okay? And thinking about how they've managed to do that, we need to think about the kind of stimuli that they encounter in their everyday environment. So let's take an example, Tom and Jerry. We've got little mouse is out having a really lovely day, walking around in the sunshine, the music's in the major mode. Suddenly a big horrible cat comes on the scene and the mouse is much less happy and the music immediately moves into the minor. And children learn these connotations without any musical training at all. And again, with Linda Pryn and Beata Hermelin, we looked at perception of major and minor mode in children with autism, and we found that they categorised the musical mode in the same way as typically developing children, with one caveat. So the group, we saw no group difference when we analysed the data, but we had one statistical outlier in the autism group. It's one child who seemingly performed very, very badly. And this child was an extremely bright little boy who I knew had about a year of music lessons, and I knew had absolute pitch. And so I asked him what he thought he had been doing when he was doing the experiment, and this is what he told me. D minor, F minor, B flat minor, I really like those keys. But in contrast, A major, C major, and F sharp major, I think they're really unpleasant. So he had categorised the keys on an affective basis, but it's just that it wasn't cultural, it was personal. Okay, so musical mode is only one very small part of music. Music's a very, very rich stimulus. So the obvious next question was whether or not they'd recognise emotions in real music. At the time, I had a friend who's a flute player, and she was working in the RPO and the LSO, and she went around and talked to all of her fellow musicians about different kinds of emotional expression in music, and they gave her lists of pieces of music that they thought were happy, sad, fearful, angry, etc. We piloted those on 200 typically developing children. And the way that we ran the experiment was that we produced a sequence of pictures that were laid out in front of the children, and then they heard the musical examples one after another in sequence, and every time one finished, they had to point to a picture that they thought went with that piece of music. So, as an example, the two angry children were paired with the fight scene from Prokofiev's Romeo and Juliet, and the Triumph Man with a Cup was paired with a bit of Beethoven's Fifth Symphony, so you can kind of get the idea. So what the results showed that really how well you did on this task depended on how good your language was. And that was true for typically developing children as well as children with ASD. But importantly, what we found was that children with ASD that had normal language, levels of normal language on standardised language tests, were performing this task at the same level as age-matched typically developing children. So we didn't see any deficits on this experiment. Now, going back to the Tom and Jerry example, we know that we can work out what music means emotionally in quite a cognitive way. There are lots of gestures and cues in music that are associated with specific emotions. So in a way, these two experiments don't tell us very much about what people with ASD feel when they're listening to music. But we do have some evidence from different types of studies that is quite important. So this is a study that Rory Allen carried out on musical perception in adults with ASD and typically developing controls, and he played the participants emotional music interspersed with periods of silence. Now he found that when he asked the two groups to describe the music to them, there were quite impoverished descriptions in the ASD group. They did not talk in a very flowery way about the music, but actually when you looked at the level of autonomic or emotional arousal in response to the music, there was no difference across the two groups. So the ASD people were feeling as much of the music, even though they might not have such good verbal descriptors for it. And this is a study that I carried out in collaboration with the Danish Centre for Music in the Brain in Aarhus. It was an fMRI study that was led by Lena Gebauer, and she used fMRI to look at the neural correlates of emotion recognition in adults with ASD and typically developing comparison participants. And what she found was that the groups engaged similar neural networks, but participants with ASD showed higher levels of arousal in response to happy music. So what we've seen then is that if we go back to Hyoran's idea that autistic people don't have musical affinity, and that is because of their social communication problems, we can see from the empirical data that they've got intact structural understanding of music. They understand the cultural connotations of what music means, and at a physiological and neural level, they are showing similar patterns to typically developing people. So there's absolutely no evidence at all that we see deficits in music perception in autism. So really the only question to ask them was, why do they like music and what do they use music for? So this was another study carried out by Rory Allen in collaboration with Elizabeth Hill and myself. There were 12, not 2, intellectually able adults with autism, and they answered a series of questions about how they used music in their everyday lives. So there were structured and semi-structured interviews that was probing early musical experience and education, the development of musical taste through adolescent lessons, and current habits of musical listening and or playing. So it's just looking at what music is there for, in their opinion. And it was a qualitative study. This is what the analysis showed. So when asked what is it about music that makes you want to listen to it, you can see that there were a huge range of different kinds of responses. People might like the music because of its expressiveness, its social connections, which was an interesting structure, the technical competence of the performer. I'm going to read out a couple of the comments because it gives you much more of a feeling for the kind of responses that we had. So, as for exhilaration, I loved Beethoven 6, the thunderstorm, the calm after the storm. You can feel all the emotions you want in that music. I love classical music. But also Radiohead. Their music has such power, and also like Pink Floyd and Jefferson Airplane. I mean, the fact that it was quite a powerful organ with like 32 feet reed stops, which has a very deep sound, almost an octave below the piano. That pitch is almost outside of human perception, but the power of it, you know, really adds resonance. It sort of gets right in my roots. If I was a tree, it would get right in my roots. And then, why do you listen to music? So again, for all sorts of reasons, because it causes movement, therapeutic reasons, aesthetic reasons, achievement, the performers, the performance, a sense of belonging, again an interesting one, and all sorts of things to do with mood, whether or not it alters mood or it reinforces the kind of mood that you're in, and again some comments. If you feel tense or whatever, you want something to calm you down, then you listen to Japanese music. When I've been feeling depressed, I've listened to certain music, and I would claim the music healed me. With autism, you tend to feel dead a lot of the time. So music is the key that unlocks the emotions. It was interesting, again, thinking about the association between social skills, social abilities, and musicality, that there were quite a few examples of individuals using music in quite a social kind of way. So when someone's released a classic album and you listen to it, I think, I'm part of something great now. There's something about pop music, it's the image, and to do with people of my generation rather than adults inflicting on you. So we have a Bolsh teenager there. I'm reminded when I hear music of people who like it. I have a friend who is a good New Order fan, and he introduced me to New Order. When I listen to them, it reminds me of him. My sister likes particular music. When I listen to that, I'm reminded of her. Me and my mates, Tony and Simon, we are very much into Phil Spector. So adaptationist theories propose that music's important because it brings us closer to each other. And it was hypothesized that people with ASD who have social communication impairments will not appreciate or engage with music. And I presented today a range of empirical studies that really refute this hypothesis. And I actually would like to propose an alternative hypothesis, which is that people with ASD have an increased affinity with music compared to typically developing people. And that's because music provides all the rewards that are associated with social and emotional interactions without any of the negative consequences of having to deal with other people when you have ASD. Okay, so I'm going to end by, I've worked with very many wonderful collaborators and PhD students over the last 20 years, but this list is people that have really worked with me on looking at strengths in people with neurodevelopmental disorders and also looking at music. And finally, the last word has to go to a group of young musicians with ASD.
In case you don't know me, I'm Andy Bremner, Head of Psychology, so I just wanted to add a few words about what PAM means to the department as a kind of wonderful colleague that we have. It's such a great talk. It's really quite moving for me, I think, to sort of see the impact of PAM's research in changing what could be quite a lazy, sort of a lazy idea about how children with autism, because they don't have such rich social, communicative interactions, some developmental psychologists could sort of rule music out for them, and I think it's so important that PAM's made a contribution to really challenge that in what's clearly a meaningful way. PAM is, I think, definitely a product of Goldsmiths, but also, of course, a wonderful contributor towards Goldsmiths. So PAM's been here in one shape or form since the early 1990s, as an undergraduate part-time, as a postgraduate student part-time, then as a research assistant, and as a lecturer, and as a senior lecturer, reader, and now professor, so 7 roles in total, I think. Sort of through that time, she's not just been doing research, of course, but she's been a truly important member of the department, both in terms of her teaching, which the students absolutely love, but also just by being a fantastic colleague, because she, I hesitate to say this in a way because I think it doesn't do Pam credit, and she might not like it, she might tell me off. But in a way, Pam's kind of the department Agni aunt. She's served in that role as postgraduate tutor for many years, but also in that role for other colleagues for academics. And I remember as a young lecturer arriving in 2005, I remember lots of conversations with Pam which were incredibly helpful in helping me kind of orient in the ways that I ought to approach the job. I remember in particular very helpful advice on teaching. I was a bit frustrated because I've been trying to teach undergraduates, first year undergraduates, in a very enthusiastic way about neural network models and cognitive processes, and I remember talking to Pam about it. She very tactfully helped me with suggesting that I might want to think about teaching them something they were interested in. which and now my teaching's better as a result. So just to round up and just to thank Pam again for a wonderful talk and for a wonderful contribution to the department. Thank you. There are refreshments outside.